All right, econ friends, welcome back to our final video for this particular topic. So in our first video, we opened up with GDP, and then in our most recent video, we jumped over to inflation. Now what we need to do to wrap this process up is circle back one last time to GDP, okay? Why do we have to do that? Well, let's jump into it. But basically, we learned in our first video in this series that while GDP is a great thing, we had learned that price changes can affect GDP. And that sometimes if there's like unstable prices like inflation, rapid inflation, the GDP numbers will change, but they won't reflect the actual underlying production. Okay, we discussed that. So in this final video, we're going to take our opening GDP knowledge and then take our inflation knowledge and kind of put those together to make a couple of last minute adjustments, make a few tweaks to the GDP that we talked about before, and now get it to a point where it's a really valuable tool. Sounds like a lot, but it's really not that bad. So let's jump into it. So again, like I said, earlier we mentioned that because GDP measures the total size of the economy in dollar terms, and that was critical, because it measures in dollar terms, GDP can be a misleading measurement when prices are not stable. In other words, inflation, what we just talked about in that last video, inflation can make GDP numbers unreliable. And if you go back to that first video, we gave a simple example. I think it might have been cars. I forget what it was. But you can have production stay the same. You can have no change in production, which would really be no growth in the economy over time. But if inflation is happening and the prices of those items are going up, on the surface, it's going to look like the GDP is growing. But that growth is reflecting inflation, not output level. And GDP is supposed to reflect output level. So we have to come up with some kind of a way to strip, to remove, to correct for that pricing issue. We do this, we correct for these inflation effects by calculating what we're going to call real GDP. So what we covered before was just GDP. You could also call it nominal GDP if you were so inclined. But we're now moving from, regular GDP or nominal GDP into this idea of real GDP. And real GDP is a measure of GDP, but critically, it's a measure of GDP that uses a constant set of prices tied to our price basket that we've learned about last time, that uses a constant set of prices to control for changes in the price level. You can think of real GDP, how about this, as inflation adjusted GDP. You can also think of real GDP as GDP measured in constant dollars. And in fact, you'll hear those terms used interchangeably in economics. You'll hear, oh, it's a real value, or, oh, it's an inflation adjusted value, or we're measuring this variable in constant dollars. You'll hear different variations of this jargon, of this terminology. It all means the same thing. It means that we're stripping away the effects of inflation. So we're going to think of this as real GDP, which we can also consider or think of as inflation adjusted GDP or constant dollars GDP, okay? In general then, anytime the word real accompanies an economic indicator, it implies that we have adjusted that data to account for inflation. In contrast, what we know as nominal values, nominal having the same Latin root as the word for name, right? That nominal values are values that are expressed in current dollar terms. So how about this? The GDP that we discussed in our opening video was nominal GDP. But nominal GDP has a big flaw. It can be really affected and it can be misleading because of inflation. So we're going to move from nominal GDP to real GDP, from current dollars to constant dollars, from non-inflation adjusted to inflation adjusted. And it's going to be real GDP that gives us cleaner data. Okay? We're going to rely on several formulas to make this adjustment. It's not that difficult. It's important that you get your formulas right and that you do some practice, but with some practice, you can get them, okay? So how are we going to make these adjustments from nominal to real? Well, there's a couple ways, okay? Number one, to determine real GDP for a current year in terms of base year, okay, this is important. We're still going to be talking about base years here. In fact, whenever we're talking about real GDP and we're measuring it in terms of constant dollars or, adjusted dollars, we're always comparing, we're always referencing the base year, okay? So real GDP is inflation adjusted GDP. It's also GDP in constant dollars, and it's the base year that serves as the starting point, as the peg for that comparison. So what's our first formula? To determine the real GDP for a current year in terms of a base year, it's simply here. The real GDP for year 2 or for like the current year is going to be equal to nominal GDP multiplied by this fraction here, the price index in year 1 divided by the price index for year 2. This is the kind of thing you can look at this formula. It might make some sense to you, it might not. The best way to do it, just jump in. And we'll do some questions together when we're in live time. But don't get overwhelmed by these formulas. It's not that bad. You just need to do some practice problems to really get your head thinking around those adjustments. Once you see the real numbers, it'll make a lot of sense. You see, oh yeah, that GDP, that nominal one, it was artificially high. We got to strip that down a bit. We're going to do that via price levels. Account for inflation rates, which is what price levels measure. So you'll get it. Just do some practice. Okay. So our first formula, if you're given current year GDP as well as price indexes, you can translate and get real GDP. You can also convert any year's nominal real GDP. You can also convert any year's nominal GDP into real GDP with this formula. Real GDP, this is a really important one. This is the one that's used often. Real GDP is equal to nominal GDP divided by the price index times 100. Okay. Notice that all of these, when you look at these formulas, you should be seeing that they're all some variation of either the new minus old divided by old formula, or they've got some variation of a price index inserted to strip away, usually through division, to strip away the inflation effects, okay? So when you look at these formulas, obviously look at them, write them down, practice them, but really think, what's it doing? Well, it's trying to equate a nominal value to a real. How's it doing that? It's stripping away the inflation by, for example, dividing by a price index, okay? So again, number 2, to convert any year's nominal into real, critical formula, real GDP is equal to nominal divided by the price level times 100. And in fact, this leads us to a third formula, which is a really useful formula outside of just GDP and broadly in economics. To convert any nominal value into a real value. And in this case, I'm using, year Z and year Y, which is confusing. It's best to just plug numbers in and actually crunch them out, okay? But to convert any nominal value to a real value, here's your formula. The product price, that could be the price of an item, it could be the price of a basket, it could be a wage level, it could be any price, because prices are a pretty constant thing in economics, and prices measure lots of stuff, okay? The product price in any given year is equal to the product price divided by the index for a different year multiplied by the price index for that year. Again, my friends, I've done this for a long time. I know that right now your mind is swimming with alphabet soup and formulas and year one and year two and year Y and year Z and constant year and current year and base year. It's overwhelming. Keep it simple. Let's do a practice one to flesh it out. Real life example here from the world of baseball. In 1931, some guy named Babe Ruth, who was considered to be one of the best baseball players ever, he earned $80,000. Okay, so again, in 1931, the old Babe earned $80,000. You might think, that's nothing, I make more than that now. Clearly, I'm better than Babe Ruth. Maybe not. Maybe you are, I don't know. Again, 1931, the Babe earned $80,000. FYI, this was like $5,000 more than the president made that year. So this guy, Babe Ruth, was earning more than the American president. But here's the big thing. It's hard to visualize what 1931 was, and it's really hard to understand what $80,000 in 1931 meant. So we can do an adjustment. We know that the CPI in 1931 was equal to 15.2. That's the price index. We also know that the CPI in the year 2017 was equal to 244.5. That's also the price index. Notice that if you wanted to, since you have the price index for 1931 and you have the price index for 2017, you could actually calculate the inflation rate between 1931 and 2017 by doing new minus old divided by old. You would do 244.5 minus 15.2 and divide that by 15.2. So, within this data, there's a lot of potential use. But here's what we're really asking here. If Babe Ruth made $80,000 in 1931, given this CPI data here, what would Babe's salary have been in 2017? In other words, what salary level in 2017 would be the equivalent of $80,000 in 1931? Well, to do that, we just take this formula here, we plug it in. But let's go really clean, okay? Let's do this. The salary in 2017 would simply be equal to the salary in 1931 divided by the CPI in 1931 times the CPI in 2017. Notice that I just took this formula here, I brought it down, but instead of Y's and Z's, which are really confusing, I just put in actual years to keep it real clean. So we know that the salary that the Babe would have earned in 2017, had everything stayed equal, will be equal to his 1931 salary divided by the 1931 CPI times the 2017 CPI. Seen a different way, it would be $80,000 divided by 15.2 times 244.5, which would basically mean that if the Babe was earning $80,000 in 1931, to have the same purchasing power, to have the same salary impact, he would have to earn, his salary would be $1,286,842. Seen a different way, Babe Ruth would have to earn $1,286,842 in 2017 in order to have the same buying power, the same purchasing power, the same dollar power as $80,000 in 1931. A lot of formulas. I know it's confusing, but once you practice with them, it allows you to make really important comparisons, not just between different people today, but also across time. Okay, that's the adjustment from nominal GDP to real GDP. Finally, we need one more adjustment, and we're going to call it a day. In much the same way that we adjusted nominal to real to account for inflation, we have to do one more adjustment. We have to adjust real GDP to account for population differences across different countries, or to account for population changes within a single country over time. So we took an adjustment from nominal GDP to real GDP to strip away to account for inflation effects. The final refinement we have to do is to account for population effects. This should make some sense to you. Imagine two countries that have a similar GDP, but one country has 1 billion people and one country has 1 million people. You can't compare those apples to oranges. You need to account for the impact of population differences, and that's both across different countries today, but also about population differences within a country over time. Yes, the US real GDP has grown steadily over time, but so has its population. So we have to make an adjustment. We make this adjustment by calculating a critical number called real GDP per capita. Real GDP per capita is real GDP per person. It serves as the best measure. So we've gone from nominal to real, and now from real to real per capita. It is real GDP per capita that serves as the best measure we have of a country's rate of output, because it not only accounts for inflationary effects, but it accounts for population effects. When you think of real GDP per capita, what you're really considering, what you're really calculating is how much did each citizen, on average, right, on average, how much did each citizen within an economy contribute? What was the overall productivity of each citizen on average? And since we said a while ago in a previous video that output was associated with income, what would we see as the average output level, and therefore by extension, the average income, the average receipt, the average gain to a citizen within an economy? We have to correct for population. We do it with real GDP per capita. Once you have this and understand it, you can really see a lot of different things. If you take a look at this, this is a graph that shows real GDP per capita. It's measured in American dollars to keep it constant. And you can see that we have the US, Australia, Germany, and a bunch of other countries. Okay. This chart, more than any other, would give you a really firm, solid idea of how different countries do comparatively, because we've taken nominal and adjusted for real, and then we've taken real and adjusted for population. You can see that when you do this, the United States still remains at around, 51,000 or so, the leader globally as measured by real GDP per capita. It's interesting to note that China has a real GDP that is on par, and by some measurements, even bigger than America's. You might have heard people say that China has overtaken America as a productivity leader because the Chinese real GDP is approaching that of America's, which may be true. But that doesn't tell the full story, because the population of China is significantly bigger than that of America. When you factor in the population aspects and you move from real GDP to real GDP per capita, you get a much better sense. This is the reason why both China and India, which have very big economies, have relatively low economic rankings, and in fact still have lots of poverty within those countries. It's not that their economies aren't big, it's that when you adjust those economies by their very big populations, their real GDP per capita are relatively low. It also explains why countries like Japan and Canada, which along general measurements may have low real GDPs, actually are considered high performers and are wealthy. Canada and Japan have relatively low real GDPs, but they also have relatively low populations. When you adjust out, you get a much more robust and a much better sense of what a country is contributing, how they're growing, and really if they're wealthy or not. Okay? With that said, because real GDP per capita is real GDP per person, our formula is very easy. We simply take real GDP, divide it by the population, and we have real GDP, I should have put here, pardon me, per capita. There it is. You have real GDP, divide by the population, you get your formula, and now you have real GDP per capita. And that's the figure that really matters. Because at the end of the day, macroeconomics is about economic growth. And economic growth, by definition, occurs anytime real GDP per capita has risen. So with that, my friends, we're done with this topic. By way of quick review, we started off with GDP. We understood the components, the expenditure method, the income method. We know it's really important. We then jumped over into inflation and learned about its effects. Once we had the inflation knowledge, we were able to come back to GDP in this video and make some adjustments. So we moved from nominal GDP to real GDP, from real GDP to real GDP per capita. And now that we have real GDP per capita, you're equipped with the critical tool to determine if there has been economic growth. Economic growth, by definition, occurs anytime real GDP per capita has risen. And knowing what you know about formulas, you can actually track the rate of growth for any economy over time by simply taking the real GDP per capita in a current year minus the real GDP per capita in a previous year and dividing it by the previous year. Once again, our handy dandy new minus old divided by old formula kicks in. We can use this formula to track inflation rates. We can also use it to track economic growth rates. We simply substitute out the price index, sub in real GDP per capita. And with that, you're well on your way to understanding, interpreting economic data, and building up ways to think about good policies to make economies and therefore people better. And that's what good economics is. My friends, it's been a tedious lecture with a lot of formulas and alphabet soup. Thanks for sticking with me, and I'll see you next time.